Okay, so next topic we are going to discuss is SCTP, wherein SCTP error control. In the case of TCP also, we had discussed about error control. The reason is basically we consider like TCP provides reliable service, or TCP is a reliable transport protocol. Okay, so even SCTP is also considered to be reliability. Okay, we said like in SCTP, we are taking the best from TCP and best from UDP and combining, right? So SCTP also provides a reliable service. So it basically uses selective acknowledgement to report the status of receiver side. Okay, whether it has received properly or not, are there any missing blocks or any duplicates that we have. All those things are useful to handle error control with respect to SCTP. Okay, so here also we will see how things are done at receiver side, how things are done at sender side, how you are sending data chunks, generating selective acknowledgements. All these things we will be looking at. Okay, so with respect to receiver side, again, if you remember the selective like acknowledgement, whatever we are sending, the format is as shown in this figure. Okay, so let us see with respect to receiving queue, what is the status. We have received till 23 without any issue, but again I had a block here. Okay, 24, 25 I did not receive, 26, 27, 28 I have received. Okay, 29, 30 I didn't receive, again 31, 32, 33, 34 I have received. So what we are doing is basically we set cumulative TSN points to the TSN number till which we have received without any issue, right? So we are talking about that one here. Cumulative TSN is 23. Okay. Then window size we are saying is 1000 and we have provided last acknowledgement till 20. Okay. Next, we are saying we have received out of order from where to where? We received from 26 to 28. Okay, out of order. Then 31 to 34, I have received out of order. Then 22nd one, I received twice. 31 also I received twice. Okay, so whenever I want to send selective acknowledgement, I need to check if cumulative TSN value greater than last acknowledgement or not. Okay, in case that is true, then I am eligible for sending that selective acknowledgement, right? So what we are doing here, you can see we are saying cumulative TSN is 23 because till 23 I have received without any issue. Receiver window size I have 1000. Okay, we are talking about how many number of gap acknowledgement blocks I have received. So as you can see, we have two gap acknowledgement blocks. So we are telling about that one. Then how many duplicates I received? Two. I'm also giving the details. From this particular stage, like cumulative TSN is 23, right? From that point, we start to give offset address or offset TSN value. So in this offset TSN, what we are doing? Gap acknowledgement block 1 is starting at 3. That means I did not receive 1 and 2, but I received 3, 4, 5. So we are saying it is starting at 3 and ending at 5. Again, second block is starting at 8 and it is ending at 11. Now, when you receive this data till 23, I'll say like the receiver has received. Then by looking at gap acknowledgement blocks, I'll consider like gap is starting at 24. Okay, but you are saying like gap acknowledgement block is starting at 3, which means I did not receive 1 and 2. Okay, that means 24 and 25 receiver has not received. Like that, sender will come to know by looking at this offset address. Okay, and we are also providing the details of duplicate TSN number. Okay, I have received 22 twice, 31 twice. So whether we are providing complete information here, I am providing acknowledgement. I am providing, are there any issues with respect to missing packets? I am also providing with respect to duplicate packets that I have received. Okay, so complete information at the receiver side has been advertised by selective acknowledgement. Okay, Clear what is happening here?
Sir, can you repeat once again, sir? 22.
22 and 31 you are saying?
Yes, sir.
Okay, so basically, we will be having receiver queue and these parameters out of order queue, duplicate queue. In duplicate queue, we will be writing the number of the corresponding chunk which we have received multiple times. So 22 and 31, if you observe from the data provided here, they have been received multiple times. So to the sender side, we are just saying like these are the two things which we are receiving multiple times. Okay, so there is no point like in sending this one, it will come to know like they have been duplicated, but sender has nothing to do with that. But if you have gap acknowledgement blocks, you need to handle that one. Clear?
Yes, sir.
Okay. Anything else that that is not clear? See, you don't have to hesitate because you are sitting in this just to understand. In case anything you are not understanding, you have to ask. Okay. So if everything is clear, I'll go for next slide. Clear for everyone?
Yes, sir.
Yes, sir.
Okay. Okay, now let us see with respect to sender side what is happening. Okay. This is the queue which we were maintaining. Okay. Along with that, we will also keep retransmission queue. Okay. So outstanding chunks from 23 till 36 we had transmitted previously. Okay. And we are waiting for transmission of 37. And if you see receiver window size, previously it was telling 2000 and in transit I have 1400 bytes. Okay. So here till like with respect to retransmission queue, why we have 21 and 22 is either let us say RTO timeout happened, retransmission timeout happened, because of which I moved 21 to this retransmission queue, or let us say I have received 4 selective acknowledgements. Okay. In TCP, we used to call 3 duplicate acknowledgements, right? Or 4 TCP acknowledgements also we can say. So in this case, we are saying we received 4 selective acknowledgements, let us say for 22nd. So I am giving the information like 21 and 22, they have not been received at the other side. Okay, this is before I send this acknowledgement. Okay, remember whatever the information we are providing here, before you send this one, the status of sender side is this. Okay, so sender maintains two things. One is sending queue, other one is retransmission queue. I'll be adding a particular chunk in retransmission queue whenever we receive 3 duplicate acknowledgements or 4 selective acknowledgements or whenever timer expires. In any of these cases, I'm going to move the things in retransmission queue. Clear about these things? Okay. On reception, on reception of selective acknowledgement, what we are doing, see here. So just to recap, what we said is we are saying till 23 I have received, 26 to 28 I have received, 31 to 34 I have received. That is what we are saying. Okay. And acknowledgement what we are providing, cumulative TSN, we provided 23 and we are saying like these are the gaps I have. So what we are doing here is 26 to 28 we are removing, 31 to 34 also we are removing because they have been already received by receiver side. There is no point in maintaining those things. But 29, 30 we did not receive, 35, 36 also we don't know whether they have been received or not. Okay. So because we are advertising till 34 itself. Okay. So you can see here we are maintaining 29, 30, 35, 36 in outstanding chunks. We are updating cumulative current TSN value. We are updating receiver window size. We are updating in transit. Okay, in transit is 29, 30, 35, 36. Okay, that is in transit 400. But we are not including anything about 24 and 25 because for 24 and 25 we are considering either retransmission timeout happened or 3 duplicate acknowledgements or 4 selective acknowledgements have been received. So we are keeping those two things in retransmission queue. Clear about 24 and 25?
Yes, sir.
Okay. Now we need to assume, like as I said, we had some timer value set for 24 and 25, and we could not get acknowledgement for 24 and 25. So we are just adding them in retransmission queue, and we will be going with exponential backup. That is new transmission, the RTO timeout value. We are just doubling that. That is as per exponential backup. And even if we receive four duplicate acknowledgements also, four selective acknowledgements also, we are moving them into retransmission queue. Then if you see 29, 30, 35, 36, we have already transmitted and we are waiting for getting acknowledgement for that one. So we are keeping in transit value as 400. Okay. So sender side we are updating based on the selective acknowledgement which we have received. Okay. So sending data chunks, what we will be doing is we have a rule whenever we want to transmit data chunk. Okay, we need to give highest priority to retransmission queue. Okay, so I have 24 and 25 here, right? Before I can transmit 35 and basically, which is the segment which I have to transmit as per the rule, I have to send 37. Okay, because that is pointed by current TSN. But whenever we have something waiting in retransmission queue, I need to give priority to 24 and 25. Okay, that is what we are saying. Retransmission queue has highest priority. Total size of the data chunk or chunks in the packet must not exceed receiver window size minus in transit. Okay, that is what we considered previously also. Okay, and total size also it should be less than maximum transmission unit, because without which we won't be able to have a path which carries your data segment. Okay, in previous scenario, like if you consider with respect to previous scenario, 24 and 25 they are waiting. Okay, and 37 also that is the one which needs to be transmitted. Okay, but some implementation, like some implementations of SCTP, they won't allow mixing of retransmission queue and sending queue. Okay, that means 24 and 25 they need to be transmitted separately, and 37 need to be transmitted separately. It does not allow 24 and 25 and 37 to be transmitted at the same time. But some implementations allow that. So whenever we want to send, we can send 24, 25, 37. But we need to check if the receiver window size minus in transit value is greater than the byte size of all these three chunks. Okay. Retransmission when we are doing, as we considered, whenever we have some retransmission timer expires or three duplicate selective acknowledgements, if we receive, we are going to do retransmission. Okay. Clear about how we are doing error control with respect to sender side? Clear or not?
Yes, sir.
Okay. Next we have rules with respect to generating selective acknowledgement chunks. Okay. They are also like similar to what we have seen with respect to TCP. TCP, what we said, piggybacking is there. That means we need to attach acknowledgement along with data. In selective acknowledgement also, we are doing the Same thing. Second rule, what we are considering is we need to delay sending of selective acknowledgement for at least 500 milliseconds. Okay. Same here also we are saying the same thing. And whenever we have two unordered unacknowledged chunks, immediately we need to send selective acknowledgement. That is also same rule with respect to TCP. And whenever we receive out of order packet, we need to send selective acknowledgement. Whenever we receive duplicate packet also, we need to send selective acknowledgements. So whatever we see here, all those things are similar to what we have seen in TCP. But instead of acknowledgement, we are saying selective acknowledgement. Okay. Okay. Then how congestion control is handled in SCTP. So in transport layer, basically TCP, it used to take care of congestion. Even same strategies what we have seen with respect to TCP, in SCTP also, we are following the same thing. Like slow start will be there, congestion avoidance will be there, and congestion detection. When we detect congestion, then we are going to go with multiplicative decrease. Then like TCP in SCTP also, we have fast retransmission and fast recovery. Okay. Okay. So congestion control and multi-homing need to have different values of congestion window for each IP address, because multi-homing, we said like we are going to have multiple IP addresses, right? Okay. So we need to maintain congestion window for individual IP addresses. And explicit congestion notification means like we are informing the sender whenever there is some congestion in the network. It may be like you advertise about congestion using ECN. We have seen explicit congestion notification messages are sent from receiver to sender side, right? Like that, you'll be sending information through explicit congestion notification check, so that sender will come to know about that one. So here, receiver, whenever it encounters like delayed or lost packets, then it can send this explicit congestion notification to sender. Okay. So overall, with respect to SCTP, we considered features, services, then packet formats, flow control, error control, and congestion control. Okay. These are the things with respect to SCTP. Are these clear?
Yes, sir.
Okay. So we will stop our discussion here.